Okay, so number 3 is going to be a woozy. Man, there's going to be a lot of steps here. So let's get started on it. A mixture contains 5.4 moles of water, okay, 5.4 moles of water, and 5.6 times 10 to the 24 formula units of calcium. Okay, calcium nitrate. They want to know what is the mass percent of calcium nitrate. So that means I have to find, and then they're in a mixture. So that means that I have to find the mass of each one of these and then see what the mass percent of this one is, of calcium nitrate. So because they're asking about mass, I know that I have to be dealing with grams. And neither of the things that they provided me with are in grams. But I know that because of dimensional analysis, I can go and turn these into grams. So let's start doing that. So if I start with 5.4 moles of water, I'm working on my water right now. Water. I need to get rid of moles. So I'm going to have moles at the bottom. And I know that I can go immediately from this and make it into grams. Make this into grams if I put grams on top. Grams per mole is the molar mass. That means that I have to find the molar mass of H2O, of water. Water is H2O. So I have 2 atoms of hydrogen and I have 1 atom of oxygen. I know from looking at my periodic table, let me show you just so you believe me. Nope, there we go. I know from looking at my periodic table, hydrogen is 1.008. 1.008. And there's 2 of them, so I have to multiply that by 2. And oxygen is 15.999. Oxygen is 15.999. And there's only 1, so I don't have to multiply anything. So if I go, let's use the calculator. I'm more fancy now. If I have to go and multiply 1.008 times 2 and then add 15.999 to that, that's going to equal 18.015 grams per mole. So the molar mass of water is 18.015 grams per mole. And I know that I can use this number here so that I can go from moles to grams. So I am going to write there are 18.015 grams in 1 mole. So I used my molar mass of water here. Now I can see that my moles cancel out and I am only left with grams, which is what I wanted because I'm trying to find the mass percent, so I have to be in grams. And now all that I have to do is just solve the math. Because 5.4 and 18.015 are next to each other, I multiply them. 18.015, that gives me 97.281 grams. So if they tell me that I have 5.4 moles of water, I converted my moles to grams, finding the molar mass of water, and I got a total of 97.281 grams of H2O, of water. Cool, so I'm halfway done. Now I have to find the mass of this thing, of calcium nitrate. So they tell me that I have 5.6 times 10 to the 24 formula units of calcium nitrate. Okay, so any time that they give me any atom or molecule number, I am always going to remember my conversion that 1 mole is equal to 6.02 times 10 to the 23rd atoms, molecules. In this case, it's formula units. So I can start with my dimensional analysis by getting rid of my formula units. So I know that 1 mole is equal to 6.02 times 10 to the 23rd formula units. I put formula units at the bottom because I want it to cancel out with the formula units at the top. Okay, and I'm running out of space here, so I'm gonna like move to the bottom, but first let me solve this. So if I have formula units at the top and the bottom, I'm going to cancel those out, and I am left with moles. I am left with moles because that is the only unit left. So now I'm gonna solve the math. 5.6 times 10 to the 24th, that little e that you see there is the same thing as saying times 10, divided by 6.02 times 10 to the 23rd, and that is equal to 9.3. Yep, 9.3. 9.3 moles. Cool, so now I have that, I know that I have 9.3 moles of calcium nitrate. However, I still need to find the grams of calcium nitrate because I need to find the mass percent. So I need to find grams. So if I have 9.3 moles of calcium nitrate, I need to multiply this by moles at the bottom so that my moles cancel out, and my final answer has to have grams, just how we did for water, where my final answer had to have grams. Because I have to have grams at the end, I need to have grams on top. And now I can see that my moles will cancel out and I'm only left with grams. So what is grams per mole? Yep, that's molar mass. Whoop, whoop. That's molar mass of calcium nitrate. So if you remember from our polyatomic ions list, let me look it up here real quick. So nitrate, this nitrate right here is NO3, and then it is a minus. That is the polyatomic ion of nitrate. You can access it using the resource sheet that I provided for you in your OneNote. So calcium nitrate, I know that calcium has always a 2 positive charge because it's in this group, and this group always has a 2 positive charge. Calcium has a 2 positive charge. Nitrate has an NO3 minus charge. I need to balance out these charges. I have 2 positives and 1 negative, so I need another negative charge. So my formula for this is actually going to be 1 atom of calcium and 2 polyatomic ions of nitrate. So you see how you have to bring back that naming? It doesn't go away, guys. So this is how I can find my molar mass. I have to know how many atoms there are. So here we go. I need to find the mass of calcium, which is 40.078. 40.078. And then I have to find the mass, let's do of just NO3 first. Let's just do the inside first. NO. So N, nitrogen, is 14.007. Oxygen is 15.999, but I have to multiply that by 3 because I have a little subscript. And let's figure out what that is. So 15.999 times 3 is 47.997. 47.997. And now I can add both of these values together, the 14.07 and the 47.997, so that I can find the molar mass of just NO3 plus 14.007. Cool, and that is the molar mass of NO3, 62.004. 62.004. Okay, and now you're like, cool, we're done. We found the molar mass. But no, remember, we only found here was NO3. We still have to multiply this number by 2 because of this subscript. This subscript is telling you that there are 2 polyatomic ions of nitrate, so we have to multiply this number by 2 times 2, and that is 124.008. 124.008. And you're like, cool, we're done. But I'm like, no, you're not done actually, because let me get another highlighter here. This is only this part of the compound. We still need to add the calcium. So you have to add the calcium plus this. We're almost done with this molar mass. This is the part that takes the longest. So 124.008 plus 40.078. And that is the molar mass of calcium nitrate. So let me write that down. Is equal to 164.086 grams per mole. All right, now we got it. 164.086. So now we can go back. I know this is so long, guys. I'm so sorry. So now we can go back and finally finish our dimensional analysis. I know that there's 164.086 grams in 1 mole. I can see, right, so molar mass of calcium nitrate. I can see that there's moles at the top and the bottom, so that's going to cancel out. And all I have left to do is just solve the math. So 9.3 and 164.086 are next to each other, so I have to multiply those. 0.86 times 9.3, and that is 1525. Let's say 1526. There it goes. 1526 grams. So now we have found that I have 97.281 grams of water, and I have of calcium NO3, and I have 1526 grams of calcium nitrate. So now that I have my masses for both compounds that I have in this mixture, I can finally find my mass percent. So the formula for this, they're asking you the mass percent of calcium nitrate. So the formula is mass percent is equal to whatever I am trying to find the percent of. In this case, it would be calcium nitrate over the total mass. And then you multiply all that by 100. So the total, I'm going to do it right here. Let me box off this area since I'm running out of space. So the what I'm trying to find is the mass of calcium nitrate, and I have this one. So it is 1526 divided by the total mass. So the total mass is this plus this in the mixture. So 1526 plus 97.281, and that is my total mass. So 1623.281, and then I have to multiply this by 100 times 100. So let me pull out my calculator again. I attached a resource for an online calculator if you guys don't have that, one of these calculators. So 1526 divided by 1623.281 times 100. And there we go. This is my final answer. After all these years, I finally arrived. There's 94% composition of calcium nitrate. And boom, that's how you do this problem. Isn't that beautiful?